Welcome to ROAV Perfect classes. In this video, I will discuss about data structure. First, I am going to give introduction of data structure. Data structure. Data structure, the name indicate that itself it organizes the data in memory. It organizes the data in memory. There are different ways of organizing data in memory, and you can say in C language we use array concept. Array is a collection of memory elements in which data is stored sequentially. In other words, we can say that array stores same data elements in a continuous way, and this organization of data is done by help of array of data structure. And there are also other ways to organize data in memory. Data structure is not any programming language. Programming language like C, C++, Java, etc. It is a set of algorithms. It is a set of algorithms which can use in any programming language to structure the data in memory. To structure the data in memory. To structure the data in memory, there are a number of algorithms which were proposed, and all these algorithms are known as abstract data types. These abstract data types have further set of rules. Now I am going to discuss types of data structure. There are two types of data structure. First is primitive data structure. Second type is non-primitive data structure. In primitive data structure include built-in data types. In non-primitive data structure include further two types. First, linear data structure. Second, non-linear data structure. And non-primitive data structure is also known as composite data structure. And built-in data types are like int, float, char, boolean, etc. And in linear data structure include array, string, linked list, stack, queue. And non-linear data structure include tree and graph. Or we can say that data structure also divided in two parts: static data structure and dynamic data structure. Static data structure is a type of data structure where size is allocated at the compile time. When we allocate size at the time of compile, that size will be fixed. That is the maximum size and it will be fixed. So that's why it is called static data structure, which cannot be changed. And dynamic data structure is a type of data structure where size is allocated at the run time. And maximum size is flexible, which can be changed according to need. Now next point that is important: types of operation which are performed in data structure. Types of operations on data structure which are performed on data structure. First type is searching. Second type is sorting. Third type is insertions. And fourth type is updation. And fifth type is deletion. These are the 5 types of operation which are performed on data structure. Searching means we can search for any type of element in data structure. That is known as searching. Sorting means if we want to sort the elements in data structure either in the form of ascending order or descending order. Third is insertion. Insertion means when we want to insert any new element in data structure, then we use insertion operation. Updation means when we want to update any element in data structure. If you want to replace any element with old element, then we use updation operation in data structure. Deletion means when we want to delete any node from the data structure, or you can say any element from the data structure, then we use the deletion operation on data structure. Now next point is, what are the advantages of data structure? Why we use data structure, and what are the advantages of data structure? First main advantages of data structure is its efficiency. And second is reusability. And third advantages is abstraction. abstraction. Means you can say efficiency means if we want a data structure according to own choice. If we choice of data structure for implementing a particular abstract data type is proper, it makes the program very efficient in terms of time and space. If we use abstract data type properly, then it make program very efficient in terms of time and space. Reusability means data structure provides reusability source that multiple client programs can use data structure. And abstraction, data structure specified by abstract data type, which also provides level of abstraction. The client cannot see the internal working of data structure, that is known as abstraction. So it does not have to worry about the implementation part. The client can only see the interfaces. Now, next topic is data structure algorithm. What is a data structure algorithm? Data structure algorithm. Before going to understand what is a data structure algorithm, first of all, you have to understand what is an algorithm. What is algorithm? Algorithm is a process, is a set of rules. Algorithm is a set of process, set of rules to perform any type of calculations or to solve any type of problems by a computer. That is known as algorithm. The main definition of algorithm is that it contains finite set of instructions that is carried out in a specified order to perform specific task. And we can say that it is not complete program or code. It is just a solution, just a logic of a problem. It is just logic of a problem which can be represented either as an informal description or you can use the flow chart. You can use flow chart. Now, next important point is characteristics. What are the characteristics of an algorithm? What are the characteristics of an algorithm? First characteristics is input. Second is output. Unambiguity. Fourth, finiteness. Fifth, effectiveness. And sixth, language independent. First is input. Input means an algorithm has some input values. We can pass 0 or 1, some input value to an algorithm. Output means we will get one or more output at the end of an algorithm. That is output. Unambiguity means when an algorithm is unambiguous, that means instructions in an algorithm should be clear and precise and simple. Finiteness means algorithm should be contain limited number of instructions. When an algorithm includes limited number of number of instructions, that is known as finiteness. That is known as finiteness. Means instructions should be countable. Effectiveness means an algorithm should be effective. As such, each instruction in algorithm affects the overall process. Language independent means the language of algorithm should be independent so that instructions in algorithm can be implemented in any type of languages with same output. Now, next topic is data flow of an algorithm. Data flow of an algorithm. Data flow of an algorithm. First, we will solve in this problem. We will see what is the problem. Then we will see what type of algorithm is used for solving that problem. Third, what type of input will be given to algorithm. And then processing unit will be execute, and after that we will get finally result. You can say problem means a problem which can be real world problem, which we need to create a program or set of instructions. The set of instructions is known as algorithm. Set of instructions is known as algorithm. And now algorithm will be designed for a problem. First of all, you have to tell what is your problem. Then you will design according to that problem algorithm. After designing algorithm, you will give the input and then you will execute your giving inputs. That means processing unit. Then you will find at the end result, that is known as output. After designing an algorithm, the required and desired inputs are provided to that algorithm. And then input will be given to processing unit, and after that processing unit will produce the desired result, and the output is known as the result of program. Why we need algorithm? Why we need algorithm? First, scalability. Second, performance. There are two main points. That's why we use algorithm. Scalability means it helps us to understand the scalability. When we have a big real world, we need to scale it down into small steps. Scalability means to break down the big problem into small steps so that you can easily analyze that problem. Performance means the real world is not easily broken down into smaller parts. If problem can be easily broken down into small steps, that means that problem is feasible. That problems give you performance. Now, next, we can take here one example of algorithm, how to write algorithm. If you want to sum of two numbers, through any programming language, for this, these steps should be followed. Means algorithm. First of all, you have to start your algorithm. Then you will take input, take input two numbers like num1, num2. After that, you will implement formula, that is sum is equal to num1 plus num2, that is step 3. Then step 4, find the result and show the result, that is sum of two numbers. These are the steps of an algorithm to solve any type of problem. Step 5, stop the program, stop the algorithm. Now next point is, what factors of an algorithm that we need to consider for designing an algorithm. Factors we should consider. First factor, modularity. Second, we should consider correctness. Then maintainability. Fourth, functionality. Fifth, robustness. Then algorithm should be user friendly, and algorithm should be consider simplicity, and algorithm should be consider extensibility. These are factors which should be considered when we plan regarding algorithms of any type of problem solving. Now, what are the importance of an algorithm? First main importance is theoretical importance. Theoretical importance means when any real world problem is given to us and we break that problem into small parts, small modules. To break down the problem, we should know all the theoretical aspects. And practical importance means when we know that theoretical aspects of algorithm, then practical implementation should be considered. The importance of algorithm can be considered as both practical and theoretical. Now, what are the issues which we face when we design a algorithm? Issues of algorithms. First issue we will face, how to design algorithm. This is first issue which we will face when we make a algorithm. Second, how to analyze that algorithm efficiently, or you can say how to analyze algorithm efficiency. What's the efficiency of algorithm? How to analyze that efficiency of algorithm? These are two main issues which we face when we designing an algorithm. Now next point is approaches. What type of approaches of algorithms which we use for designing algorithm? What type of approaches of algorithms are used for designing algorithm? There are following types of approaches which are used after considering both practical theoretical importance of designing of an algorithm. That first approach is brute force algorithm. Brute force algorithm. Brute force algorithm means the general logic structure is applied to design an algorithm. When we implement general logic structure, general logic structure is implement to design an algorithm, that is known as exhaustive search algorithm. Exhaustive search algorithm, which searches all the possibility to provide the required solution. And such type of algorithm are two types. First is optimizing. Second is sacrificing. Optimizing means we have to find all the solution of a problem and then we have to take out best solution out of that given solutions. If value of best solution is known, then it will terminate if the best solution is known. Sacrificing means as soon as the best solution you have to find out, then it will be stop the algorithm. Second approach, we can use divide and conquer. In divide and conquer, we can say that it's very implementation of an algorithm. It allows us to design an algorithm in a step-by-step variation. It breaks down the large algorithm to solve the problem in different methods. It also allows us to break down the problem into different methods, and you can calculate valid output that will be produced for valid input. The valid output is passed to some other function. Now next is a greedy algorithm. Greedy algorithm is an algorithm structure which makes an optimal choice on each iteration with the hope of getting best solution. It is easy to implement. It has a faster execution time. There are very rare cases in which it provides optimal solution. And third approach is dynamic programming. Dynamic programming, it makes the algorithm more efficient by storing intermediate results. And it follows 5 different steps to find the optimal solution for the problem. First, these steps are, first of all, you should break down the problem into sub-problems so that you can find out the optimal solution. In the second step, after breaking down the large problem into smaller parts, you have to find optimal solution out of these sub-problems. Third step, then store the result of sub-problems is known as memorization. When you store the result of sub-problem, that is known as memorization. After that, you have to reuse that result so that you cannot be recomputed for the same sub-problems. And last step is, finally, you calculate the results of complex problem. Now you can say There are different types of steps. First step, break down large problem into smaller problems. And second step, find out optimal solution. Third step, store the result. That is known as memorization. Fourth, reuse the result according to your demand recalculation. Reuse the result when you want to recalculate. Fifth step, finally, calculate result of complex problem. And next approach is branch and bound algorithm. In branch and bound algorithm, we can say that this can be applied to only integer programming problem. Branch and bound algorithm, when we use integer programming problem, we can use it only in integer programming problems. This approach divides all the set of feasible solutions into smaller subsets, and these subsets are further evaluated to find the best solution. And next is randomized algorithm. Randomized algorithm, as you can see in regular algorithm, we have predefined input and required result. Those algorithms which have some definite set of inputs and required output, and they follow some fixed steps, that is known as deterministic algorithm. And what happens that when the random variable is introduced in the randomized algorithm, in a randomized algorithm, some random bits are introduced by algorithm, and you can say that it added in the input to produce output, which is random in nature. Randomized algorithm are simpler, efficient than deterministic algorithm. And last approach is backtracking. Backtracking means it is an algorithm technique which used for solving the problem recursively. We can remove the solution if does not give the satisfaction results according to constraints of a problem. Then you can reverse. Now, major categories of algorithms are: first, you can use algorithm for sorting the items in a certain order, used for sorting. Second, searching, used for searching, deleting, update, or insertion, insert. Mainly these five categories for which algorithms are used. Sort means algorithm developed for sorting the items in a certain order. Search means algorithm developed for searching the item inside a data structure. Delete means algorithm developed for deleting the existing elements from the data structure. Insert means algorithms are developed for the inserting an item inside a data structure. Update means algorithm developed for the updating existing element inside a data structure. Now next point is algorithm analysis. How to analyze algorithm? Algorithm can be analyzed in two levels. First level, before creating algorithm. Second level, after creating algorithm. There are two types of analysis of algorithm. First, before and creating algorithm. Second, after creating algorithm. There are two analysis algorithm. First is a before creating algorithm, that is known as priori analysis, and after creating algorithm is known as posterior analysis. In priori analysis, it is a theoretical analysis of algorithm which is done before the implementing any type of algorithm. We follow various types of factors for implementing algorithm like processor speed, so that which has no effect on the implementation part. After creating algorithm, posterior analysis means it is a practical analysis of the algorithm. It is used after the studying theoretically problems of algorithm. Then we use practical analysis, which is achieved by implementing algorithm, and we using here any type of programming language. And this analysis basically evaluate the how much running time and how much the space which are taken by the algorithm. That is known as posterior analysis. Now there is some complexity of algorithm. Algorithm complexity. There are two types of algorithm complexity. First is a time complexity. Second is a space complexity. Time complexity means the time complexity of an algorithm is the amount of time which is required to complete any execution of program. The time complexity of an algorithm is denoted by big O notation. Big O notation is denoted by is used for the denoting time complexity. Big O notation is the asymptotic notation. It is known as asymptotic notation to represent to time complexity. Time complexity is mainly calculated by counting number of steps to finish execution. For example, here we have given, we have to find out, for example, we have to find out sum of 1 to 10 numbers. So here we can say, we assume sum is equal to 0. Then we take any type of loop, whether for, while, do, while loop, in which we will put the condition I will be start from 1 to 10, and sum is equal to sum plus I, and this will be show that, and then will be then we get the result sum. When we suppose we have to calculate sum of n number, or we have given fixed numbers 1 to 10, then loop ends with that sum holds the sum. In this case, in this problem, we will be calculate time complexity by using loop statement. The loop statement will be at least 10 times will be repeat. If value of n increases, then time complexity also increases. while complexity of code return sum will be constant as its value is not dependent on value of n, but it will be provide the result in one step only, or you can consider worst time complexity. It is the maximum time taken for any given input size. Means any program which takes more time to execute the result, that we can say that is the worst time. Worst time. When time increase, that means that is the worst time complexity. It is the maximum time taken for any given input size. Space complexity means space complexity is the amount of space which is required to solve the problem and produce a result. Similarly, time complexity, space complexity, both are denoted by big O notation. Big O notation. And for an algorithm, the space is required for following purposes. First, we for store the instructions, program instructions, then store program instructions, or store constant values, or you can say store variables, or you can say function calls, track function calls, jumping statements, etc. Jumping statements, etc. The extra space which are required by algorithm, excluding input size, that is known as secondary space, auxiliary space, and space complexity. Consider both spaces, auxiliary space and space used by input. Here space can be used by two ways. First is used by space first used by input, or second space which is except input size, take the extra space for the execution of program, for the storing program instruction, for storing constant value, variables, function calls, jumping statement, etc. That increases the space complexity. And space complexity is a combination of input size plus auxiliary space. Thank you for watching my video. If you like my video, please like and share my channel with your friends. I will post next video related to data structure, more contents like types of algorithms, search algorithms, sort algorithms. There are different types of algorithms which are used in data structures, and types of data structures, and practical questions of data structure I will post in next coming videos.